Something changed on December 25th. Not in space. Not with 3I Atlas, which continues its relentless journey outward exactly as orbital mechanics predicts. The change happened here. On Earth. In the astronomical community. In the carefully measured words of researchers who spent months building a case for something extraordinary and then, overnight, began tearing that case apart with the same hands that constructed it. If you want to follow this investigation through the Jupiter encounter, if you want to see the analysis of data that's being kept from public view, subscribe now and turn on notifications. Because we're not letting this story die quietly. We're going to track every observation, examine every gap in the archive, and push for the transparency that the scientific community is supposed to embody but has suddenly abandoned. December 26, 2025. 1 week after the closest approach. 1 week after 3I Atlas passed within 269 million kilometers of Earth and gave us the best opportunity we'll ever have to study an interstellar visitor up close. And the silence is deafening. Not the silence of an object that revealed nothing interesting, but the silence of people who saw something they can't talk about. The silence of doors closing, of narratives being locked down, of data gaps appearing in archives that should be comprehensive. The world looked up during the flyby, watched with anticipation as this third confirmed visitor from beyond our solar system made its pass. And then the world moved on, satisfied by press releases assuring everyone that the object was natural, fascinating but explicable, nothing to worry about. Just another chunk of ice and rock from a distant stellar system, melting as it approached our sun and fragmenting under stress as comets do. But if you're actually looking at the data, if you're watching what the researchers are saying versus what they're not saying, if you're comparing the excited speculation from October to the sudden disciplined uniformity of December, you see something else entirely. You see a story being rewritten in real time. You see anomalies being explained away with mechanisms that don't quite work. You see gaps where there should be observations and silence where there should be debate. The physical behavior of 3I Atlas during its December 19th closest approach was extraordinary by any measure. Mass loss rates that exceed what objects of this size should be capable of sustaining. Jets that formed with geometric precision and maintained orientations that defy simple thermal models. Electromagnetic signatures that don't belong in the emission spectrum of sublimating ice. A color shift that's happening in the wrong direction as the object recedes from the sun, fragmentation patterns that look less like breaking apart and more like controlled deployment. These aren't subtle anomalies. They're screaming inconsistencies that demand explanation. And the explanations being offered, when they're offered at all, require stacking coincidence on top of unlikely circumstance on top of special case assumptions. The natural explanation is becoming more extraordinary than the artificial hypothesis it's trying to replace. Before we dive into what the data actually shows, before we examine the specific observations that are being minimized or hidden, you need to understand what's at stake. Because the Jupiter encounter is coming. In January 2026, just weeks from now, 3I Atlas will pass within 52 million kilometers of the gas giant. And that encounter will be the ultimate test. If the object is natural, Jupiter's immense tidal forces should tear it apart. If it's something else, if it has structural integrity beyond what rubble piles possess, it might survive intact. Might do something. Might reveal what all the silence has been trying to conceal. The timeline tells you everything you need to know about the shift. In October, when 3I Atlas was first being characterized after its discovery in July, the atmosphere in the astronomical community was electric. This was the third interstellar visitor, following Oumuamua in 2017 and 2I Borisov in 2019. And unlike Borisov, which behaved exactly like a normal comet and provided little fuel for speculation, 3I Atlas was showing features that reminded researchers of Oumuamua's puzzling characteristics. Avi Loeb, the Harvard astrophysicist who's made headlines for years arguing that Oumuamua might have been artificial, was at the forefront. He was everywhere. Podcasts. News segments. Academic preprints. Conference presentations. Building the case that 3I Atlas shared too many kinematic similarities with Oumuamua to be dismissed casually. He suggested openly that it might be a probe. that it might reveal technological features at perihelion when solar heating would trigger any dormant systems. That we should be watching carefully because this could be the discovery that changes everything. And he wasn't alone. The Breakthrough Listen project, funded specifically to search for evidence of extraterrestrial technology, pointed their radio telescopes at the object. They were anticipating that the close approach might trigger a wake-up signal. That if the object was indeed a probe, passing near Earth might activate transmission protocols. The excitement was genuine. The hypothesis was on the table, debated seriously by serious researchers in serious venues. Fast forward to today. December 26th. The flyby happened. The object did exhibit unusual behavior. And the response from Lib and his colleagues has been a complete reversal. By the morning of December 25th, Christmas Day, the tone shifted. Press releases from the Galileo project and Breakthrough Listen suddenly emphasized exclusively natural processes. The artificial hypothesis wasn't just downgraded. It was erased. Scrubbed from the narrative as if it had never been seriously considered. Lub, previously the champion of keeping an open mind about technosignatures, is now quoted discussing exotic outgassing of nitrogen ice and tidal fragmentation mechanisms. The same researcher who spent months priming the world for potential discovery is now explaining why there's nothing unusual to see. The transition wasn't gradual. Wasn't a slow accumulation of data leading to refined conclusions. It was overnight. Binary. On December 24th, speculation was rampant. On December 25th, the narrative was locked down. That timing is significant, because December 24th was when the high-fidelity telemetry from the JUICE mission was downloaded and processed. JUICE, the European Space Agency's Jupiter Icy Moons Explorer, was fortuitously positioned to observe the flyby with instruments designed for studying magnetic fields and particle interactions. The spacecraft wasn't supposed to be watching comets. It's on its way to Jupiter. But the trajectory brought it close enough to 3I Atlas during the Earth encounter that ESA repurposed some of the instruments for observation. And whatever JUICE recorded, whatever data came down on December 24th, seems to have triggered the narrative shift. As if a meeting was convened. A briefing was given. A decision was made about what could and couldn't be said publicly. And by Christmas morning, the unified message was clear: this is a natural object, the anomalies are explicable, move along. The sudden absence of technical detail in the press releases is glaring. Breakthrough Listen issued a statement saying no narrowband radio signals were detected. That's the conclusion. But they haven't released the raw data. Haven't published the waterfall plots that show the full spectrum analysis. Haven't provided the detailed methodology that would allow independent verification. They've given us a verdict without showing the evidence. This is not how open science works. When you make an observation, particularly an observation related to a high-profile hypothesis, you publish everything. You show your work. You let other researchers examine your data and challenge your conclusions. That's the peer review process. That's what distinguishes science from authority-based knowledge systems. But what we're seeing looks more like the sanitize and release protocols used in defense and intelligence sectors. Conclusions without data. Assurances without details. Trust us, we looked, we didn't find anything worth mentioning. That might be acceptable for classified national security information. It's completely inappropriate for astronomical observations. Which raises the uncomfortable question, did this become a national security issue? If JUICE or ground-based observatories detected something that suggested artificial origin, that information would instantly become the most sensitive intelligence in human history. It would bypass the academic journals and go straight to government situation rooms. The researchers involved would be placed under non-disclosure agreements. The data would be classified. And public statements would be carefully managed to prevent panic or international incidents. In that scenario, the scientists aren't villains. They're constrained. Forced to downplay findings they'd otherwise be shouting from rooftops. Required to emphasize natural explanations even when the data points elsewhere. It would explain the coordinated nature of the reversal. The uniformity of messaging. the sudden absence of dissenting voices. But it's speculation, and we need to be careful about constructing elaborate theories without evidence. The problem is that the evidence itself is what's missing. The gaps in the public record are the story. Start with the physical observations. The mass loss rate recorded during peak activity was 1.8 million kilograms per second. Let that number sink in. 1.8 million kilograms. Every second. For an object that's estimated to be only a few kilometers across, that's an enormous, almost catastrophic rate of material shedding. Comets lose mass when they approach the Sun. That's normal. Solar heating causes ice to sublimate, turning directly from solid to gas. The gas expands rapidly, carrying dust particles with it, creating the coma and tail that make comets visible and beautiful. But the rate at which this happens depends on the object's size, composition, and distance from the Sun. For 3I Atlas at 269 million kilometers from Earth and somewhat closer to the Sun during perihelion, the expected mass loss rate based on standard cometary models would be orders of magnitude lower than what was observed. Maybe tens of thousands of kilograms per second for a particularly active comet. Not nearly 2 million. To sustain that kind of outgassing, the object would need to be either much larger than estimated or composed almost entirely of highly volatile materials that sublimate far more readily than water ice. But the size estimates come from multiple independent observations. They're not perfect, but they're not off by factors of 10. And the spectroscopic data shows a mix of ices, not some exotic supervolatile composition. So where's the mass coming from? If the object is shedding 1.8 million kilograms per second and maintaining structural integrity, it either started much more massive than we think or the mass loss isn't coming from simple sublimation. It's coming from somewhere else. From some process that releases material at rates thermal heating can't explain. And it's not just the amount of mass. It's how the mass is leaving. Standard cometary outgassing is chaotic. You get jets forming on the sunward side where heating is most intense. Those jets are tied to the surface geography. As the nucleus rotates, the jets sweep across the sky from our perspective, creating spirals and arcs in the dust distribution. The overall effect is a diffuse coma that's brightest near the nucleus and fades gradually with distance. What JUICE and ground-based observations captured was different. The formation of distinct, coherent jets that weren't diffuse at all. These were structures extending hundreds of thousands of kilometers into space, maintaining definition that simple aerodynamic modeling can't explain. In the solar wind environment, gas expanding from a nucleus should disperse rapidly. Turbulence should break up any structure. But these jets remained coherent. Remained visible as distinct features rather than blending into a general haze. And they were sun-facing. This is crucial. In normal cometary physics, jets point away from the Sun because that's the direction gas expands when it's heated. Solar radiation warms the surface, ice sublimes, gas escapes, and radiation pressure plus solar wind push the material outward, away from the Sun. That's why comet tails always point away from the Sun regardless of the comet's direction of motion. But the jets on 3I Atlas were oriented toward the Sun, pointing inward rather than outward. To make material move sunward requires either ejecting it from the night side of the nucleus with enough velocity to overcome radiation pressure, which requires enormous energy, or some mechanism that actively directs the flow inward despite the natural tendency to expand outward. The official explanation being offered is that we're seeing a perspective effect. That the jets are actually pointing away from the Sun, but our viewing angle makes them appear to point inward. But the geometry doesn't support that. Multiple observation stations at different positions confirmed the sunward orientation. This isn't an optical illusion. It's real material moving in a direction it shouldn't move if thermal sublimation is the only process at work. The spectral analysis of the jets adds another layer of mystery. The composition is unusual. Yes, there are the expected volatile ices, carbon dioxide and carbon monoxide, the stuff we see in most comets. But there are also heavy concentrations of metals, specifically nickel and iron, in quantities that suggest a core composition unlike the fluffy, porous aggregates typical of comets. Comets form in the cold outer regions of planetary systems. They're made primarily of ices with some rocky material and dust mixed in. The rock content is usually silicates, similar to what you find in asteroids but in much lower concentrations. Finding significant amounts of metals, particularly iron and nickel, is unusual. It suggests formation conditions different from what we associate with the Kuiper belt or Oort cloud analogues in other stellar systems. The presence of these metals has been explained as evidence that 3I Atlas came from a red dwarf system. That it formed in a protoplanetary disk around a star smaller and cooler than our Sun, where chemistry might be different enough to produce metal-rich comets. That's plausible. We don't have good surveys of comets around other stars. We don't know what the full range of compositions might be across the diversity of stellar systems in a galaxy. But it's also convenient. It's an explanation that accounts for the observation while maintaining the natural framework. And when explanations become too convenient, when they require invoking special circumstances that can't be independently verified, you have to ask whether they're driven by data or by the need to preserve a preferred conclusion. The metals are there. The concentrations are high. Whether that indicates exotic formation chemistry or something else entirely, like manufactured materials, is a question the data can't definitively answer. But it should be a question that's actively debated rather than settled by assertion. Then there are the electromagnetic surges. This is where the observations become impossible to reconcile with simple cometary behavior. JUICE's magnetometers detected bursts of electromagnetic energy coinciding with the jet activity. Not random static. Not the kind of broadband noise you'd expect from plasma interactions with the solar wind. Structured emissions. Pulses appearing at specific frequencies with timing that correlated to the object's behavior. The critical frequency is 1.42 GHz. The hydrogen line. This is the emission frequency of neutral hydrogen undergoing a hyperfine transition. It's one of the most abundant spectral features in the universe because hydrogen is the most abundant element. But it's also a frequency that's been proposed as a standard channel for interstellar communication precisely because it's so universal. Any technological civilization would know about the hydrogen line. Would recognize it as a natural choice for broadcasting. Comets don't emit at 1.42 GHz. Not naturally. They create radio emissions through interaction with the solar wind, but those emissions are broadband and chaotic. They don't show up as discrete lines at specific frequencies. And they definitely don't appear in synchronized bursts that match the object's rotational changes. What JUICE recorded were pulses. Sharp increases in electromagnetic energy at the hydrogen line, occurring in conjunction with spin-up events. Every time the object's rotation accelerated, every time it shed mass in ways that changed its angular momentum, there was a blast of radio energy at exactly the frequency you'd use if you were deliberately signaling. The natural explanation being offered is charge exchange between the solar wind and the cometary coma. That's a real process. Solar wind ions interact with neutral atoms in the coma, exchanging electrons, and those interactions can produce electromagnetic signatures. But charge exchange creates a continuous spectrum, not discrete lines. And it doesn't synchronize with mechanical events on the nucleus. What we're seeing looks like a side effect. Like electromagnetic leakage from some high-energy process operating inside or on the object. Like the radio noise you detect near electrical machinery because currents flowing through conductors create fields that radiate. If 3I Atlas has systems that draw significant power, if it's operating devices that cycle on and off in response to the object state, those systems would produce electromagnetic signatures as a byproduct. And the synchronization with spin changes is the smoking gun. Natural processes don't coordinate that way. Sublimation doesn't start and stop in rhythm with rotation changes. But propulsion systems do. Attitude control thrusters do. If the object is using its mass loss to modify its spin, if it's deliberately venting material to change its rotational state, then you'd expect to see energy pulses when those systems activate. You'd expect electromagnetic signatures coinciding with mechanical events. This is engineering, not geology. This is active control, not passive response to solar heating. And it's being observed, documented, recorded in telemetry that exists on servers and hard drives somewhere in ESA's data centers. But it's not being released. Not being made available for independent analysis. Not being discussed in the public statements that emphasize natural processes and dismiss artificial hypotheses. The wobbling of the jets is another detail that's been smoothed over in the official narrative. Early reports from the Subaru telescope in Hawaii mentioned precessional modulation in jet output. The jets weren't just pointing in unusual directions. They were moving, changing their orientation relative to the object's center of mass in what looked like deliberate vectoring. Think about rocket engines. Fixed nozzles produce thrust in one direction. But if you want to steer, if you want to control your trajectory and orientation in 3 dimensions, you need vectoring. You need nozzles that can gimbal, that can change their pointing direction while maintaining thrust. That's how modern spacecraft maintain attitude control. That's how missiles steer toward targets. The jets on 3I Atlas, according to those early reports, were exhibiting exactly that kind of behavior. They were oscillating, changing vector in rhythmic patterns that looked less like random venting from a rotating surface and more like thrust vectoring from a controlled propulsion system. In natural comets, jets are locked to surface features. If there's a vent on one side of the nucleus, it produces a jet that points in whatever direction that side faces. As the comet rotates, the jet rotates with it, sweeping across the sky. You see the jet turn on when the vent faces the sun and turn off when it rotates into shadow. Simple. Predictable. Tied to the object's rotation. But the data suggested the jets on 3I Atlas were maintaining orientation independent of the object's tumbling rotation. As if they were compensating. As if something was actively adjusting the vent direction to keep the thrust vector constant even as the nucleus spun. That's mechanically impossible for a passive crack in the surface. It implies active control. Implies systems that can sense the object's orientation and adjust output to maintain desired thrust directions. This is the wobble that's been erased from the latest papers. The observations that mentioned it have been revised. The data has been averaged, smoothed, processed in ways that eliminate the oscillations and make the jets look like steady streams of gas. The precessional modulation has disappeared from the official record. But it was there in the raw feeds. It was noted by astronomers who were watching in real time. And it can't be unseen just because it's been removed from the sanitized versions. The fragmentation patterns add to the picture. 3I Atlas is breaking apart. That's confirmed. Images show the nucleus has separated into multiple pieces, with material streaming away in structured patterns. Fragmentation is normal for comets undergoing thermal stress. The combination of heating and rotation creates forces that can exceed the object's structural strength, causing it to crack and split. But normal fragmentation is chaotic. You get irregular pieces breaking off at random times. You get debris fields that expand in all directions. You get brightness variations as chunks of different sizes tumble away on slightly different trajectories. It's messy. Disordered. The signature of mechanical failure. What the images show is different. The debris field has structure. Has sectors. The mass loss is asymmetrical in ways that look designed rather than random. It's as if the object is deliberately shedding specific outer layers while keeping a core intact. Like removing a protective shell. Like deployment rather than destruction. And crucially, the fragmentation is stabilizing the object's spin rather than destabilizing it. Normally, when a comet breaks apart, the loss of mass and the irregular ejection of fragments causes the rotation to become more chaotic. The object tumbles faster or slower unpredictably. But 3I Atlas is doing the opposite. It's using the mass loss to control its rotation. To spin up in deliberate, measured ways that suggest active management rather than passive response to stress. Objects don't do this naturally. They don't break apart in ways that improve their rotational stability. They don't shed mass to achieve specific spin states. That requires calculation. Requires knowing how much mass to eject and in what direction to achieve desired angular momentum changes. requires the kind of precision that only comes from engineered systems following programmed instructions. December 26, 2025. 1 week after the closest approach. 1 week after 3I Atlas passed within 269 million kilometers of Earth and gave us the best opportunity we'll ever have to study an interstellar visitor up close. And the silence is deafening. Not the silence of an object that revealed nothing interesting, but the silence of people who saw something they can't talk about. The silence of doors closing, of narratives being locked down, of data gaps appearing in archives that should be comprehensive. The world looked up during the flyby, watched with anticipation as this third confirmed visitor from beyond our solar system made its pass. And then the world moved on, satisfied by press releases assuring everyone that the object was natural, fascinating but explicable, nothing to worry about. Just another chunk of ice and rock from a distant stellar system, melting as it approached our sun and fragmenting under stress as comets do. The color shift is the final piece that doesn't fit the natural narrative. 3I Atlas was deep red when it was first observed. That's typical of objects that have been exposed to cosmic radiation for millions of years. High-energy particles strike the surface, altering the chemistry of ices and organics, creating complex molecules called tholins that absorb blue light and reflect red. The reddish color is a badge of age, an indicator that the object has been wandering interstellar space for a very long time. But as of December 26th, as the object recedes from Earth and from the Sun, the color has shifted toward green. Noticeably, measurably green. And that shouldn't be happening. Not now. Not while the object is moving away from the heat source. The official explanation is diatomic carbon emission. C2 molecules in the coma absorb ultraviolet light and re-emit at wavelengths that appear green to our instruments. This is a known phenomenon. We see it in comets routinely. But diatomic carbon glows green when it's being excited by UV radiation from the sun. And that excitation should diminish as the comet moves away from the sun and the UV flux decreases. 3I Atlas is doing the opposite. The green glow is intensifying even as the object gets farther from the sun. Even as the UV radiation weakens with increasing distance. That only makes sense if the UV source is internal. If the object itself is producing the radiation that's exciting the carbon molecules, if there's something inside or on the surface that's generating high-energy photons independent of solar input, that implies a power source, an energy reservoir, something that's still operating, still producing radiation, even as the object moves into the cold dark beyond Earth's orbit. Natural comets don't have internal UV sources. They don't glow brighter as they move away from the sun. They fade, dim, return to dormancy. Unless this isn't a natural comet, unless the green shift is exhaust, unless what we're seeing is ionized gas being expelled from a propulsion system that uses the object's own material as reaction mass. That would explain the color, would explain the intensification, would explain why it's happening now, during the period when the object appears to be actively maneuvering and changing its spin state. All of these observations, the mass loss rate, the sun-facing jets, the metal composition, the electromagnetic pulses, the vectoring behavior, the structured fragmentation, the green shift, each one individually can be explained through some combination of special circumstances and exotic but natural processes. Stack enough unlikely scenarios and you can construct a narrative that preserves the natural framework. But the cumulative probability matters. When you need 5 or 6 low probability explanations to account for what you're seeing, when each anomaly requires its own special pleading, you have to ask whether the simpler explanation is being rejected not because the data rules it out, but because accepting it is uncomfortable. And there's one more anomaly, the most glaring, the most suspicious, the missing X-ray data. The Chandra X-ray Observatory was scheduled to observe 3I Atlas during closest approach. X-ray observations are critical for understanding high-energy processes. Natural comets are faint in X-rays, showing only weak emission from charge exchange between solar wind and cometary gas. If the object has internal power sources, if it's operating systems that require significant energy, it should be bright in X-rays, potentially blazing. The observation logs confirm that Chandra was pointed at the target. The exposure times were recorded. The telescope executed the observation, but the data hasn't been released. No quick-look images, no preliminary reports, no spectrum. The public archive shows that the observation occurred, but the results are absent, missing, withheld. The official excuse is calibration issues or processing delays. These things happen. X-ray astronomy is complex, and data reduction can be time-consuming. But quick-look images for high-profile targets are usually released within days. Preliminary analysis appears in astronomical telegrams within a week. For 3I Atlas, we're approaching 2 weeks post-observation, and there's nothing. Just empty folders and vague promises that data will be released when it's ready. In the context of all the other anomalies, in the context of the coordinated narrative shift, and the sudden silence from researchers who were previously vocal, this missing X-ray data is a red flag the size of Jupiter. If the object is dark in X-rays, if it shows only the weak emission expected from a natural comet, that data would be released immediately. It would be used to support the natural explanation, to show that despite all the other oddities, there's no evidence of high-energy processes that would indicate technology. The fact that the data is being withheld suggests it shows something else, something that doesn't fit the narrative being constructed, something that would raise questions the authorities aren't ready to answer. Because if 3I Atlas is bright in X-rays, if it's emitting at levels inconsistent with natural processes, that's the evidence that can't be explained away. That's the observation that forces serious consideration of artificial origin, regardless of how uncomfortable that conclusion might be. And that's what might be sitting on servers somewhere in NASA's data centers, locked behind access restrictions, classified or embargoed for reasons that won't be publicly disclosed. The smoking gun that proves we're dealing with something other than a comet, but that we're not allowed to see because the implications are too profound for uncontrolled release. This is speculation. We don't know what the X-ray data shows. We don't know why it's being withheld. We don't know if there's a mundane technical reason or if there's deliberate suppression. But the pattern is clear. The data that would most definitively answer the question of natural versus artificial is the data that's missing from the public record. And that absence speaks louder than any press release assuring us everything is normal. Because if everything was normal, if the observations confirmed the natural explanation beyond doubt, there would be no reason to withhold anything. The data would be flooding out. Researchers would be publishing. The story would be unfolding in real time through the normal channels of scientific communication. Instead, we have silence, coordination, narrative control, and a growing gap between what the raw observations suggest and what the public is being told. The Jupiter encounter is coming, and whatever is being hidden now might not stay hidden when the object passes through the most intense gravitational and magnetic field environment in the solar system. When the stress test happens, when natural and artificial predictions diverge most dramatically, if 3I Atlas is a rubble pile comet, Jupiter should tear it apart completely, should create a debris stream that spreads across millions of kilometers, should destroy whatever structural integrity remains after the fragmentation we've already seen. If it's something else, if it has engineered strength, if it's actively maintaining cohesion through internal systems, it might survive, might pass through the encounter intact, might emerge on the other side still functioning, still maneuvering, still doing whatever it came here to do. That's the test we're approaching, the moment when the ambiguity might resolve, when the observations might become clear enough that no amount of narrative control can obscure what we're actually looking at, and the silence will either be vindicated or shattered. The researchers who reverse their positions will either be proven prudent in their caution or exposed as participants in a cover-up. The data will either support the natural explanation definitively or reveal that we've been lied to about what's passing through our solar system. January 2026, just weeks away. The deadline for truth approaches whether the authorities are ready for it or not. The object speeds toward Jupiter. The instruments prepare. The observers watch. And somewhere in classified briefing rooms or in the private communications of researchers bound by non-disclosure agreements, people who know what was really detected during the Earth flyby wait to see whether Jupiter will confirm their conclusions or contradict them. The story of 3I Atlas is far from over. The silence is just the intermission. The real climax is coming when the object enters Jupiter's domain and the physics become impossible to hide behind careful wording and sanitized press releases. And we'll be watching, analyzing every observation, comparing official statements to independent data, pushing for the transparency that science demands and that the public deserves. Because this matters. Whether it's a comet or a probe, whether the anomalies are natural or designed, whether we're being told the truth or being managed to prevent panic. This is the story that could change everything about how we understand our place in the universe. And it's being hidden, controlled, managed by people who think they know better than the public what we can handle knowing. But the truth has a way of emerging. The data exists, the observations were made. And eventually, through leaks or official release or independent discovery, we'll know what actually passed through our neighborhood in December 2025. The silence can't last forever, and Jupiter might be the event that breaks it wide open. The energy budget doesn't work. That's what keeps coming back when you try to make the natural explanation fit. Energy has to come from somewhere, has to be accounted for in any physical process. And when you calculate how much energy would be required to do what 3I Atlas is doing, the numbers don't balance against what solar heating alone can provide at that distance. Start with the spin-up. The object's rotation period has changed dramatically over the past 48 hours. Not a gradual shift over weeks as thermal effects slowly alter the angular momentum, a rapid acceleration, the kind of change that requires torque. Substantial torque, applied quickly, and torque requires force, and force requires energy, and the energy has to come from somewhere. In a natural comet, the energy source is the sun. Solar radiation heats the surface. Ice sublimes. Gas expands. If the venting is asymmetric, if more gas escapes from one side than the other, you get a rocket effect. The object pushes against the escaping gas and the gas pushes back, creating thrust that can change the rotation over time. This is well understood physics. We see it in many comets. It's called non-gravitational acceleration, and it's a standard feature in cometary dynamics. But the magnitude matters. The amount of thrust you can generate from outgassing is limited by how much solar energy is available to sublimate ice and how efficiently that sublimation converts to directional thrust. At 269 million kilometers from Earth and somewhat closer to the Sun during the period of peak activity, the solar flux is substantial but not enormous. Certainly not enough to drive the violent mass loss we're seeing, while simultaneously providing the energy to spin up a multi-kilometer object in a matter of hours. The calculations are straightforward. Take the observed mass loss rate, 1.8 million kilograms per second. Calculate how much energy is required to sublimate that much ice. Water ice requires roughly 2.8 million joules per kilogram to go from solid at cometary temperatures to gas. That's the heat of sublimation plus the energy needed to warm the ice to the sublimation point. For 1.8 million kilograms, you need about 5 trillion watts. Continuously. For hours. The solar constant at Earth's orbit is about 1,400 watts per square meter. At the distance 3I Atlas was during peak activity, maybe 1,000 watts per square meter accounting for the inverse square law. If the object has a cross-sectional area of maybe 10 square kilometers, being generous with the size estimate, it's intercepting roughly 10 billion watts of solar energy. Total. Assuming perfect absorption and perfect conversion of that energy into sublimation. You're short by a factor of 500. The Sun isn't providing anywhere near enough energy to account for the observed mass loss. Not even close. So where's the energy coming from? The natural explanation requires assuming the object is much larger than we think, which would increase the intercepted solar energy, or that the composition is dominated by super volatile ices that sublimate at much lower energy costs than water, or that there are internal heat sources from radioactive decay or tidal heating or some other mechanism that supplements the solar input. Each of these is possible. Each requires specific assumptions about properties we can't directly measure, and each, individually, might account for some of the discrepancy. But you need all of them operating together, all aligned in exactly the right way to make the energy budget balance. That's when explanations start to feel contrived, when you're stacking assumptions to preserve a conclusion rather than following where the data leads. The alternative is that the energy is coming from inside the object, from stored reserves, from power systems that don't depend on solar input, from batteries or reactors or some other technology that can deliver trillions of watts on demand regardless of the local radiation environment. If 3I Atlas has an internal power source, everything else makes sense. The mass loss isn't sublimation driven by solar heating, it's propellant being deliberately vented to create thrust. The energy to heat and expel the material comes from onboard systems, not from the sun. The rapid spin-up is achievable because you're not limited by how much solar energy you can capture. You're drawing from reserves accumulated over however long the object has been operating. And that explains the green shift. If the power source produces radiation as a byproduct, if it's generating UV or higher energy photons through nuclear reactions or some other process, those photons would excite the carbon in the exhaust plume, would make it glow green, would create exactly the intensifying emission we're seeing as the object moves away from the sun and whatever systems it has continued to operate. This is where the missing X-ray data becomes critical, because high-energy power sources produce X-rays, nuclear reactors produce X-rays, fusion systems produce X-rays. Even advanced battery technologies operating at high current densities can generate X-ray Bremsstrahlung radiation as electrons interact with materials. If Chandra observed 3I Atlas and detected strong X-ray emission, that's the signature of internal power. That's the observation that can't be explained through natural processes. That's the evidence that would force acknowledgement that we're dealing with technology, regardless of how uncomfortable that conclusion makes everyone. And that's probably why the data is missing, why it's being held back, why we're getting calibration excuses instead of results. Because releasing X-ray images showing a bright source where there should be only faint natural emission would trigger questions that the current narrative can't answer, would undermine the careful messaging about exotic but natural cometary behavior, would prove that the energy budget doesn't balance and that something other than the sun is powering what we're seeing. The vectoring of the jets becomes even more significant in this context, because if you have power to spare, if you're not limited by how much solar energy you can harvest, you can operate active control systems, can run motors or actuators or electromagnetic field generators that adjust the direction of your exhaust, can maintain thrust vectors independent of your body's rotation, can execute maneuvers with precision that passive outgassing could never achieve. The early observations described the jets as maintaining orientation despite the object's tumble, described them as compensating for rotation to keep thrust aligned with specific directions. That's active attitude control. That's spacecraft behavior. And it requires sensors to measure orientation, computers to calculate corrections, and actuators to implement those corrections. It requires systems, infrastructure, design. Natural objects don't have these capabilities. They can't sense and respond, can't adjust their behavior based on feedback. They're passive, deterministic. You can predict what a natural object will do based on its current state and the forces acting on it. But 3I Atlas is exhibiting what looks like goal-directed behavior, like it's trying to achieve specific orientations and rotation rates, rather than just responding randomly to thermal stress and outgassing. This is where the skeptics have their strongest argument, where the demand for extraordinary evidence is most justified, because claiming that an object is exhibiting intelligent control, that it's operating systems and executing maneuvers, is an enormous claim. It requires not just that technology exists, but that it's here, in our solar system, passing through our neighborhood at exactly the moment we're capable of detecting it. The timing seems too convenient, the probability seems too low, and the natural explanation, however contrived it needs to be to fit the observations, is still more probable than the alternative. Still the safer bet, given how little we know about the full range of cometary behavior across different stellar systems. Except the timing might not be coincidental. If there's a network of these objects, if they're passing through stellar systems routinely, and we've only recently developed the capability to detect them, then finding one isn't unlikely. It's inevitable. We've detected 3 in 8 years. Oumuamua 2I Borisov, now 3I Atlas. That's a detection rate consistent with there being hundreds or thousands passing through at distances and velocities we can't currently observe. As our survey capabilities improve, as Vera Rubin Observatory comes online and can detect fainter, faster objects, the rate will increase. We might find that interstellar visitors are common, that they're constant traffic rather than rare anomalies. And if they're common, if they're infrastructure or probes or natural wanderers being used by civilizations that know how to exploit them, then encountering one isn't surprising. It's expected. But we're not there yet. Don't have the statistics, don't have enough examples to distinguish between genuine anomalies and natural variation in a population we're only beginning to sample. 3I Atlas stands alone, strange but not definitively artificial, anomalous but not impossible to explain naturally given enough special assumptions. Unless the X-ray data breaks the ambiguity, unless what Chandra saw was so clearly inconsistent with natural processes that no amount of special pleading can account for it. Then the conversation changes. Then we're forced to take seriously what the cumulative evidence is suggesting, even if each individual piece remains debatable. The structured electromagnetic pulses are another piece that's difficult to dismiss. The fact that they appeared at 1.42 GHz at the hydrogen line is too specific to ignore. That frequency is a natural choice for communication, is universally recognizable to any civilization that understands atomic physics, is exactly where you'd broadcast if you wanted to be noticed by technological observers. Natural processes can produce radio emission at many frequencies, but they produce broadband noise. Spread across the spectrum, you don't get discrete lines at specific frequencies unless you have mechanisms that are selective, that preferentially emit at particular energies. And while there are some natural processes that create spectral lines, they're usually in very specific environments like Mars's in star-forming regions or in the atmospheres of certain types of stars. Comets don't have these environments, don't have the conditions necessary to create stimulated emission at precise frequencies. Their radio emission is thermal or shock-driven or created by charge exchange, all processes that produce continuous spectra rather than lines. So finding strong emission at 1.42 GHz, appearing in pulses synchronized with the object's mechanical behavior, looks artificial, looks designed, looks like exactly what you'd expect if systems were operating and leaking electromagnetic energy as a byproduct. The counter-argument is that we're seeing what we want to see, that the hydrogen line is so prominent in radio astronomy that we're over-interpreting noise near that frequency as significant when it's actually just random variation, that the synchronization with spin changes is coincidence, that we're constructing narratives from patterns that don't actually exist in the data once you apply proper statistical analysis. But the synchronization is the key. Coincidences happen, random events occasionally align, but repeated coincidences, sustained correlations over multiple cycles, become increasingly unlikely to be chance. And if the electromagnetic bursts are consistently appearing when the object changes its rotation, consistently matching the timing of mass ejection events, consistently showing up at frequencies that would be meaningful if this were technology, then at some point the coincidence explanation becomes less plausible than the design explanation. We're approaching that point. Maybe we've crossed it. The evidence is accumulating. Each observation adds weight. And the natural explanation is buckling under the load, even as it's being reinforced by official statements insisting everything is normal. The fragmentation patterns deserve deeper examination, because calling what's happening fragmentation might be misleading. Fragmentation implies breaking apart, structural failure, loss of integrity. But what we're seeing looks more controlled, more deliberate. The debris field has structure, has sectors, material is being ejected in specific directions with specific velocities, not randomly, not as you'd expect from cracks opening and pieces breaking off under stress, but in patterns that suggest intentional deployment. Think about it from an engineering perspective. If you're a probe approaching a planetary system and you want to deploy sensors or samplers or communication relays, you don't just throw them out randomly. You calculate trajectories. You eject each payload on a path that will take it to a specific location or orbit. You use the carrier's velocity and the ejection impulse to achieve desired final states for each deployed element. That requires precision, requires knowing your own state precisely, requires calculating how much impulse in what direction will result in desired separation velocities, requires active control over the ejection process, and it produces exactly what we're seeing: structured deployment with material separating in organized patterns rather than chaotic clouds. If 3i Atlas is deploying assets, if the fragmentation is actually the release of payloads that were carried through interstellar space and are now being distributed in the inner solar system, then the mass loss rate makes sense, the energy budget makes sense, the structured jets make sense. Everything fits together if you accept that this is intentional rather than natural. But accepting that requires accepting that we're being visited, that intelligence from beyond has entered our solar system, that we're not alone, and that whoever sent this object knows we're here or will know once the data gets transmitted back to wherever it came from. That's a profound conclusion, world-changing. The kind of thing that governments would want to control, would want to prepare for, would want to manage carefully rather than letting it emerge chaotically through uncontrolled scientific publication. And that brings us back to the silence, to the coordinated shift in narrative, to the researchers who were vocal about artificial possibilities suddenly emphasizing only natural explanations, to the missing data and the gaps in the public record. If a determination was made, if the accumulated evidence crossed some threshold where officials concluded that 3i Atlas is probably artificial, that information wouldn't be released immediately. It would be classified. Briefings would be conducted. Agencies would coordinate. Messages would be crafted. And the scientists who made the observations would be instructed to downplay them publicly while the authorities figure out how to handle the disclosure. That's the scenario that fits the timeline. That explains why the shift happened so abruptly, why it happened right after the high-quality data from JUICE was processed, why researchers who spent months building excitement are now backing away from their own hypotheses without showing the evidence that supposedly changed their minds. They saw something in the JUICE telemetry or in the Chandra observations or in some other data set that's not being publicly released. Something compelling enough to trigger the protocols for managing sensitive information. Something that made this stop being just an interesting astronomical observation and start being a matter of national security. And now we wait for Jupiter, wait for the encounter that might make the suppression impossible. Wait for observations that will either vindicate the natural explanation or shatter it completely. Because Jupiter is the test that can't be finessed. The tidal forces are calculable, the predictions are clear. Natural comets with rubble pile structures disintegrate when they pass through intense gravitational gradients. We've seen it happen. Shoemaker-Levy 9 is the most famous example, a comet that broke into more than 20 pieces when it passed too close to Jupiter and then impacted the planet in a spectacular series of explosions. 3I Atlas won't impact. Its trajectory keeps it at a safe distance, but the forces will still be substantial. If the object is held together only by weak gravity and weak material strength, if it's porous and fragile like most comets, Jupiter should tear it apart further, should fragment it into dozens or hundreds of pieces, should create a debris stream that spreads across millions of kilometers. If instead the object has structural integrity, if it's held together by material strong enough to resist the tidal forces, if it has active systems maintaining cohesion, it might survive intact, might pass through the encounter without additional fragmentation, might emerge on the other side, still functioning, still maneuvering, still executing whatever mission it's on. That's the divergence point, where natural and artificial predictions become distinct enough that observation can distinguish between them, where the ambiguity might finally resolve, and the observers know this. That's why JWST is being tasked. That's why observation windows are being blocked out on the schedule. That's why resources are being dedicated to what should be a routine astronomical event if the object is really just a natural comet. They're preparing for the possibility that what emerges from the Jupiter encounter is something that can't be explained away, something that forces acknowledgement, something that breaks the silence because the evidence becomes too obvious to suppress. But there's also the possibility of transmission. If 3I Atlas is a probe and it's using Jupiter for a gravity assist to increase its velocity for the journey to its next destination, Jupiter is also the perfect place to relay data. The magnetosphere is enormous, extends millions of kilometers, acts as a natural amplifier for electromagnetic signals. If you wanted to transmit information across interstellar distances, if you needed to boost your signal to reach receivers light years away, you'd position yourself near a gas giant and use its magnetic field as an antenna. The coupling would increase your effective radiated power by orders of magnitude, would turn a weak transmitter into something capable of reaching other stellar systems. This is the upload scenario. The idea that the Jupiter encounter isn't just a gravity assist, that it's the mission objective, that 3I Atlas has been gathering data during its passage through the inner solar system and is now approaching the relay station where it will transmit everything it's learned. And if that happens, if there's a high-energy electromagnetic burst from the object when it passes Jupiter, if the magnetosphere shows anomalous activity consistent with artificial transmission, then we'll know. We'll have confirmation that we're dealing with technology, that the probe hypothesis was correct, that we've been visited and studied, and that whoever sent it now knows about Earth. The detection systems are in place. Juno's instruments can measure electromagnetic activity. Ground-based radio telescopes will be listening. The deep space network will be pointed at Jupiter during the encounter. If transmission occurs, if there's a signal, we should detect it. Unless it's encrypted. Unless it's using modulation we don't recognize, unless it's at frequencies or power levels or with characteristics that make it indistinguishable from natural magnetospheric noise, then the transmission could happen and we'd miss it completely, would record data that looks normal while the actual message passes unnoticed through our detectors. That's the intelligence analyst's nightmare, that you're listening but can't hear. That the signal is there, but you lack the tools or knowledge to recognize it. That you're being told something important and you're too primitive to understand the language. If that happens, if Jupiter comes and goes without obvious anomalies, it won't prove the object is natural, won't rule out the artificial hypothesis, will just mean we're not sophisticated enough to detect what's actually occurring, and the ambiguity will persist. The debate will continue. And the silence will remain unbroken because the evidence that could force disclosure managed to hide in plain sight. But there's another scenario, one that's darker, and that explains why authorities might be so concerned about controlling information. What if 3i Atlas isn't just observing? What if it's not just gathering data for transmission back to its creators? What if it's already deployed something? Already left payloads in the inner solar system that are now operating independently? The fragmentation patterns support this. The structured ejection of material, the asymmetric mass loss. If those fragments aren't just debris, if they're functional objects released on calculated trajectories, then they might be anywhere. Might be in Earth orbit, might be at the Lagrange points, might be on trajectories that will eventually intersect with Mars or Venus or the Moon. And we might not find them, might not be able to detect objects that small if they're designed to be stealthy, if they're dark and cold and minimizing their electromagnetic signatures. They could be sitting in our orbital space right now, observing, recording, waiting for instructions or for their internal programming to trigger the next phase of whatever mission they're on. That's the scenario that would justify classification. That would explain why data is being withheld and narratives are being controlled. Because if the fragments are real, if they're technological, if they're here and we can't track them all or understand what they're doing, then we have an intelligence problem, a security problem, a situation where foreign assets of unknown capability are operating in our space and we can't neutralize them or even reliably detect them. In that scenario, public panic becomes a concern, international incidents become likely, the carefully maintained frameworks for space governance break down because they were never designed to handle extraterrestrial actors. Treaties about orbital weapons and space debris assume all actors are terrestrial. Assume we're negotiating with other nations who share basic human motivations and constraints. If the actors are non-human, if their capabilities exceed ours by margins we can't quantify, if their intentions are unknown and possibly unknowable, then the strategic calculations change completely. And the first priority becomes preventing widespread panic while you figure out what you're actually dealing with. So you classify, you restrict, you control the narrative, you assure the public that everything is normal while you marshal resources behind the scenes to track and analyze and potentially respond to threats that you don't fully understand. And you silence the scientists who want to publish, who want to share their data openly, who think transparency is more important than security. You bind them with non-disclosure agreements. You classify their observations. You ensure that the official story is the only story that reaches the public. That's how you get the coordinated reversal, the sudden unified messaging, the missing data. All the pieces that make this look like a cover-up fit perfectly if you assume that someone decided the truth is too dangerous or too destabilizing to release without careful preparation. But the truth has a way of emerging. Data leaks, whistleblowers speak, independent observers make their own discoveries. And when the Jupiter encounter happens, when hundreds or thousands of amateur astronomers and independent researchers are all watching simultaneously, controlling the narrative becomes much harder. You can suppress data from a single observatory, can classify results from a specific instrument, but you can't stop amateurs from pointing their telescopes and sharing what they see. Can't prevent the global community of observers from comparing notes and identifying anomalies. Can't maintain perfect information control when the event is happening in real time with worldwide visibility. Jupiter might be the leak point. The moment when the cover-up, if there is one, becomes impossible to maintain. When the observations become so clear and so widely distributed that official denials stop working. When the silence breaks because the sound is too loud to suppress. Or Jupiter might be the vindication. The encounter that proves the natural explanation was correct all along. That shows 3i Atlas behaving exactly like a fragmenting comet under tidal stress. That produces data so clearly consistent with natural processes that the artificial hypothesis finally dies, and the researchers who reversed their positions are shown to have been appropriately cautious rather than complicit in suppression. We don't know which scenario will play out, can't predict with certainty what the observations will show, but we know the encounter is coming. Know that in January 2026, 3I Atlas will pass through Jupiter's domain, and the physics will become unmistakable. And whatever happens, whatever the telescopes capture, we'll be here analyzing it, comparing official statements to raw observations, pushing for transparency, demanding that data be released and explained rather than hidden behind classification or processing delays. Because this matters, whether it's a comet or a probe, whether we're being visited or just witnessing exotic natural phenomena, whether the silence is about security or about suppressing uncomfortable truths. This is the story that could define how humanity understands its place in the cosmos, and it's being hidden, managed, controlled by people who think they know better than the rest of us what information we can handle. But the universe doesn't care about our information management strategies, doesn't respect our classification systems. And Jupiter is going to reveal what it reveals regardless of what anyone wants the public to know. The countdown is on, weeks remaining, the object speeds toward the encounter, the instruments prepare, the observers watch, and somewhere in classified briefings or private communications, people who know what was really detected during the Earth flyby wait to see whether Jupiter will confirm their conclusions or force them to reconsider. The silence continues, but it's fragile, and the test is coming that might shatter it completely. The Jupiter encounter isn't just another gravitational interaction, it's a stress test, a crucible, the kind of extreme environment that strips away ambiguity and reveals what objects are actually made of, both literally and metaphorically. And that's why the observation campaign being prepared for January 2026 is unprecedented in scope and intensity, not because astronomers expect to see a comet fragment, but because they're preparing for the possibility that they might see something else entirely. The tidal forces at 52 million kilometers from Jupiter are substantial, not planet-destroying, not the kind of forces that ripped Shoemaker-Levy 9 into pieces when it passed within Jupiter's Roche limit, but significant, measurable, strong enough to stress any structure that's held together by weak forces, strong enough to exploit any cracks or weaknesses in the material, strong enough to tear apart rubble piles and fragment bodies that are barely holding together. Natural comets that pass through gravitational gradients this steep either break up or they don't based on their internal structure. If they're solid, monolithic chunks of material with good tensile strength, they survive intact. If they're loose aggregates, collections of smaller pieces held together by weak gravity, they come apart. The physics is deterministic, predictable. You can calculate the forces and predict the outcome based on reasonable assumptions about material properties. For 3I Atlas, the calculations suggest fragmentation should accelerate. The object is already breaking apart, already showing signs of structural stress from whatever processes operated during the Earth flyby. Passing Jupiter should finish the job, should fragment the nucleus into multiple pieces that then spread out along slightly different trajectories, should create a debris field that becomes increasingly diffuse over the days and weeks following the encounter. That's the natural prediction. That's what happens if 3I Atlas is a comet. And observing that fragmentation would support the narrative that's been constructed, would validate the decision to emphasize natural explanations, would prove that despite all the anomalies, despite all the unusual features, we were looking at a weird but ultimately natural object. But if the object survives intact, if it passes through the tidal stress without additional fragmentation, that's a different story. That suggests structural integrity beyond what loose rubble possesses, suggests material strength or active stabilization systems maintaining cohesion against forces that should pull it apart, suggests engineering rather than geology. This is the test, the observation that distinguishes between natural and artificial with much higher confidence than anything we've seen so far. Because you can explain away unusual chemistry or electromagnetic signatures, or even the jet vectoring through exotic but natural processes. But you can't explain structural integrity under tidal stress unless the materials have properties comets don't normally have, or unless there are active systems holding the object together. And that's why JWST is being retasked, why observation windows are being scheduled months in advance, why resources are being allocated to what should be routine tracking of a known object. The authorities know this is the critical test, know that what happens at Jupiter will either vindicate the natural explanation definitively or undermine it beyond recovery. The James Webb Space Telescope is the most powerful astronomical instrument humanity has ever built. Its infrared sensitivity lets it see through dust. Its resolution can detect details that other telescopes miss. And its spectroscopic capabilities can analyze composition and temperature distributions with unprecedented precision. If there's something unusual about 3I Atlas, if there are structures or thermal signatures or emission features that indicate technology, JWST should detect them. But JWST is also controlled. Its observation schedule is managed by committees, its data flow is regulated, and unlike amateur telescopes that anyone can point at targets of interest, JWST's results go through processing and review before public release. If what it observes is deemed sensitive, if the implications are considered destabilizing, that data could be classified before it ever reaches the public archive. That's the concern. That JWST will see something definitive, will capture images or spectra that clearly show artificial features, and that those observations will disappear into the classified world, never to be released, while public statements continue to emphasize natural explanations based on less capable instruments. But JWST won't be alone. Ground-based observatories will be watching. The Subaru Telescope, Keck, VLT, major facilities across the globe with enough aperture to resolve details at Jupiter's distance. And importantly, amateur networks. Thousands of smaller telescopes operated by enthusiasts who share their data openly and immediately, who don't go through official channels, who can't be silenced or controlled. If 3I Atlas does something dramatic at Jupiter, if it lights up or maneuvers or survives in ways that look artificial, the amateur networks will capture it, will post images within hours, will compare notes and analyze and publish their findings before any official statement can be crafted. And once that information is distributed globally, once it's shared across forums and social media and independent channels, it becomes impossible to suppress. That's the vulnerability in the information control strategy. You can manage what official sources say, can classify government observations, can pressure academic researchers to downplay findings, but you can't stop thousands of independent observers from reporting what they see. Can't prevent distributed networks from aggregating data and drawing conclusions. Jupiter might be the moment when the distributed observation network overwhelms the centralized control systems. When the truth, whatever it is, emerges not through official channels but through the collective effort of observers who aren't bound by classification protocols or institutional pressures. And there's another factor, the magnetosphere interaction. Because if 3I Atlas does have internal power sources, if it's operating electromagnetic systems, passing through Jupiter's magnetic field should trigger observable effects. The field is the strongest in the solar system, extends millions of kilometers, traps charged particles, creates auroras, accelerates particles to near relativistic velocities. If the object is electrically active, if it has currents flowing or fields operating, those will couple to Jupiter's magnetosphere, will create disturbances, will produce emissions that don't occur during normal cometary passages. We might see aurora-like displays around the object itself, might see magnetic reconnection events, might see the exhaust plume, if that's what the jets are, change color or intensity as the plasma environment changes. These would be visual effects, observable with conventional telescopes, not requiring sophisticated spectroscopy or classified instruments, just imaging, just watching what happens as the object passes through different regions of Jupiter's magnetic field and seeing whether its appearance changes in ways consistent with electromagnetic interaction. Natural comets do interact with magnetic fields. They create bow shocks where the solar wind encounters the cometary plasma. They can trigger weak auroral emissions through charge exchange. But these effects are subtle, faint, requiring sensitive instruments to detect. If 3I Atlas produces strong, visible electromagnetic effects that amateur telescopes can capture, that's evidence of internal activity. That's evidence of power sources and systems operating at levels natural comets don't achieve. The radiation environment is also relevant. Jupiter's radiation belts are intense, lethal to humans, damaging to electronics. Spacecraft passing through those belts need shielding to survive. Natural comets don't have shielding, they're just ice and rock. Radiation passes through them without significant interaction beyond surface chemistry effects that occur slowly over time. But if 3I Atlas has systems, if it has electronics or sensors or computers, those need protection, and radiation shielding has signatures, mass distribution, material composition, thermal properties. If the object is shielded, if it's designed to operate in radiation environments, JWST's infrared observations might detect the thermal signatures of shielding materials absorbing and re-radiating energy from the radiation belts. This is speculative. We're projecting what we might see if certain assumptions are correct. But the point is that Jupiter creates conditions where natural and artificial behaviors diverge observably, where the predictions become distinct enough that observation can distinguish between them with higher confidence than anything previous encounters provided. And that's why the encounter matters, why it's being prepared for with such intensity, why the silence might break when the observations come in and can't be explained away through the mechanisms that have been invoked for the Earth flyby anomalies. But there's a darker scenario that needs to be addressed. The possibility that the fragmentation we've seen wasn't destruction, that it was deployment, that 3I Atlas released payloads during its passage near Earth, and that those payloads are now operating independently in the inner solar system. If that happened, if there are fragments that aren't just debris but are functional objects on calculated trajectories, then we have a search problem, need to find them, track them, understand what they're doing. And that's extraordinarily difficult because space is large and objects can be small, and if they're designed to be hard to detect, they might evade our surveys despite being relatively close. The Lagrange points are the obvious places to look. L4 and L5, the stable points 60 degrees ahead and behind Earth in its orbit, can hold objects for millions of years without requiring propulsion. If you wanted to position observers near Earth, those are the natural parking spots. And we haven't surveyed them comprehensively, haven't catalogued everything that might be there. Surveys are beginning. Resources are being dedicated to systematic searches of the Earth-Sun Lagrange points and near-Earth space for objects that don't match known catalogues. But it's slow work, requires patient observation over weeks and months to detect faint objects against the background stars. Requires distinguishing between natural asteroids that might have been captured gravitationally and artificial objects that were deliberately placed. And even if we find something, identifying it as artificial versus natural requires close inspection, requires spectroscopy to determine composition, requires photometry to measure how light reflects or is emitted, requires tracking to see if the orbit is stable or if the object is maneuvering, all of which takes time, takes resources, takes capability we're only beginning to develop. The concern driving this effort is that if fragments were deployed, if they're active, they might be gathering data, might be observing Earth and humanity with capabilities we can't assess, might be reporting back to 3I Atlas, or transmitting directly to wherever the object came from. And we wouldn't know, wouldn't detect the transmissions if they're directional or encrypted or at frequencies we don't routinely monitor. This is the surveillance scenario, the idea that we're being watched. That the flyby wasn't just a passive observation opportunity, but an active deployment of monitoring infrastructure that's now embedded in our local space. and that everything we do, every electromagnetic emission we produce, every spacecraft we launch, is being recorded and analyzed by systems we can't detect or counter. It's paranoid. Sounds like conspiracy theory. But if 3I Atlas is artificial, if the fragmentation was deployment, then it's also logical. It's what we would do if we were sending probes to other stellar systems. Position long-term observers, gather data continuously, build comprehensive profiles of any civilizations or biospheres encountered. Standard reconnaissance procedure scaled to cosmic timescales. And if that's happening, if we are being surveilled, then the silence makes perfect sense. Because publicly acknowledging that extraterrestrial monitoring systems are operating in Earth orbit creates panic, creates international tension as nations argue about who should respond and how, creates demand for military action against targets we can't reliably find or engage, creates chaos. Better to suppress, to investigate quietly, to search for the fragments discreetly while assuring the public that everything is under control and there's nothing to worry about. Better to solve the problem before admitting it exists. But the problem might not be solvable. If the fragments are sophisticated, if they're designed by a civilization thousands or millions of years more advanced than us, our attempts to find them might be futile. They might be watching us search, might be evading our surveys, might be operating freely while we fumble around with instruments barely adequate for detecting natural objects, let alone engineered ones designed for stealth. This is the humbling scenario, the one where we realize we're not in control, where we understand that if there are other intelligences operating in our space, they can do so with impunity because we lack the capability to stop them or even reliably detect them. Where we confront our own technological limitations and our vulnerability to actors who operate on different scales and with different capabilities than we can match. It's why the Jupiter encounter is so important, because if 3I Atlas survives intact, if it demonstrates capabilities that confirm the artificial hypothesis, then we know that we're not dealing with geology, know that the fragments, if there are fragments, are probably technological, know that we need to take seriously the possibility of surveillance and develop countermeasures even if we don't currently have the capability to implement them. The encounter will inform strategy, will determine what resources get allocated to search efforts, will shape policy discussions about how to respond to potential extraterrestrial presence in near-Earth space, will either validate current approaches or force complete reassessment of how we think about space security and planetary defense. And it's weeks away. The timeline is compressed, the window for preparation is closing, the object is already approaching Jupiter's gravitational influence, already beginning to feel the effects of the massive field and the intense radiation environment. And whatever it's going to do, whatever it's going to reveal, the time for speculation is ending and the time for observation is beginning. The green glow is intensifying. That's one of the most recent observations. As 3I Atlas continues moving away from the Sun, continues entering regions where UV radiation should be weaker, the green emission is becoming brighter, more prominent, more obvious in the images. If this were natural diatomic carbon emission excited by solar UV, it should be fading, should be dimming as the distance from the Sun increases and the UV flux decreases. The fact that it's doing the opposite, that the green is intensifying, strongly suggests an internal source, something on or inside the object producing the radiation that excites the carbon molecules. And the implications are clear. Internal power sources, systems operating independent of solar input, technology that continues functioning regardless of the local radiation environment, all the things that would make this object artificial rather than natural. But the data isn't being discussed. The observations are being made. Amateur astronomers are capturing images showing the green intensification, but the official statements don't mention it, don't acknowledge the inconsistency, don't explain how natural processes could produce an effect that contradicts basic physics. The silence isn't just about hiding what was seen during the Earth flyby. It's about controlling the narrative around ongoing observations, about preventing the accumulation of public evidence that contradicts official explanations, about maintaining the fiction that everything is normal even as the object continues to behave in ways that normal comets don't. And that control is becoming harder to maintain because the observations are public, the images are being shared, the discrepancies are being noted by people who understand the physics and who recognize that the explanations don't work. The narrative is cracking. The unified messaging is being challenged by distributed analysis that official channels can't suppress. Jupiter might be the breaking point, the moment when enough people are watching simultaneously that the discrepancies become undeniable. When the gap between official statements and observable reality becomes too large to bridge. When the silence breaks because maintaining it requires denying what thousands of observers can see with their own eyes. Or Jupiter might be the vindication, the moment when 3 I-Atlas fragments completely spreading into a debris field that clearly shows it was just a comet after all. When the tidal forces finish the job that solar heating started. When the natural explanation is confirmed so thoroughly that all the speculation dies and researchers can move on to studying other objects without the baggage of the artificial hypothesis. We don't know which scenario will unfold. Can't predict from the current observations whether the object will survive or fragment, whether it will maneuver or drift passively, whether it will transmit or remain silent. The data is ambiguous, the predictions are uncertain, and the only way to resolve the uncertainty is to wait and observe. But the waiting is almost over. January 2026. Just weeks. The encounter window is approaching rapidly. And when it arrives, when 3 I-Atlas passes through Jupiter's domain and the physics becomes unavoidable, we'll get answers. Maybe not complete answers. Maybe not definitive proof of natural or artificial origin, but more answers than we have now. Better constraints on what we're actually looking at. And those answers will shape everything that comes after. Will determine whether interstellar visitors remain scientific curiosities or become security concerns. Will influence how we allocate resources between pure research and defensive capabilities. Will affect public perception of our place in the cosmos and whether we're alone or surrounded by neighbors who visit occasionally but don't stay to chat. The legacy of 3 I-Atlas is already being written. Not in official reports or peer-reviewed papers, though those will come eventually, but in the conversations happening now among researchers and enthusiasts and anyone paying attention to what the data actually shows versus what the official statements claim. The object has exposed fractures in the scientific community, has revealed tensions between transparency and control, has demonstrated that when observations are sensitive enough, when implications are profound enough, the normal processes of open science can be suspended in favor of information management. And that's problematic. Because science depends on transparency, depends on the ability of independent researchers to examine data and challenge conclusions, depends on peer review and replication and the continuous testing of hypotheses against observation. When those processes are short-circuited, when data is withheld and conclusions are dictated rather than derived, the enterprise becomes something else, becomes authority-based rather than evidence-based. The missing X-ray data is the clearest example. Observations were made, resources were committed, telescope time was used, and the results, whatever they showed, are being withheld, not released to the public archive. Not available for independent analysis, hidden behind excuses about calibration and processing that don't hold up to scrutiny. If the observations showed nothing unusual, if they confirmed the natural explanation, they'd be released immediately, would be used to bolster the official narrative, would be celebrated as evidence that Chandra can detect and characterize interstellar visitors and contributed to our understanding of these objects. But they're not being released, which means they showed something else, something that doesn't support the narrative being constructed, something sensitive enough to justify withholding from public view despite the damage that withholding does to scientific credibility, and eventually that data will leak. Someone will speak. A disgruntled researcher will copy files before leaving the project. A whistleblower will decide transparency is more important than classification. A hacker will breach the systems and release everything to the public. The history of classified information is that it doesn't stay classified forever. Eventually, it emerges. When the Chandra data comes out, when we finally see what the X-ray observations actually showed, the silence will be retroactively justified or condemned. If the images show a natural comet with weak X-ray emission, consistent with charge exchange, the withholding will look like overcautious information control. Embarrassing, but not malicious. If the images show something else, if they show a bright X-ray source inconsistent with natural processes, if they provide clear evidence of internal power and artificial systems, then the withholding becomes a cover-up, becomes deliberate suppression of evidence that the public had a right to know, becomes proof that we were lied to about what's passing through our solar system. The truth will emerge. Maybe not immediately. Maybe not soon enough to affect the Jupiter observations or the immediate response. But eventually, through leaks or official release or independent discovery, the data exists. The observations were made. And you can't permanently suppress information in a connected world where thousands of people have potential access and motivations to reveal what's being hidden. 3I Atlas is fading, receding into the dark beyond Earth's orbit. By February 2026, it will be barely detectable even with large telescopes. By mid-year, it will be gone, too faint to observe, lost in the vastness of space. The window for direct observation is closing. Soon we'll be left with whatever data we've collected and whatever conclusions we can draw from that limited data set. But the object will continue. We'll pass Jupiter in January. We'll swing through the outer solar system over the following years. We'll cross the orbits of Saturn, Uranus, Neptune. We'll enter the Kuiper Belt and eventually the Oort cloud. And sometime in the next 100,000 years, we'll leave the sun's gravitational influence entirely and return to interstellar space, where it came from, where it's going, what it's carrying, what it learned during its passage through our system. All unknowns, all questions that might never be answered definitively. All mysteries that we'll debate for generations based on the fragmentary observations we managed to collect during the brief months when it was close enough to study, unless it comes back, unless the trajectory models are wrong, unless it maneuvers after Jupiter and changes its course in ways that bring it back to the inner solar system on a future pass. Then we'd have another opportunity, another chance to observe and analyze and test hypotheses. Another window to determine whether we're looking at nature or technology. But the probability is that this is a one-time encounter, that 3I Atlas will leave and never return, that our single chance to understand it was these few months from discovery to departure, and that whatever we failed to observe, whatever data we failed to collect, or that was collected but suppressed, represents lost opportunities that won't come again. That's the tragedy of the silence, that by withholding data, by managing information, by controlling the narrative rather than releasing everything and letting the scientific process work, we may have squandered the opportunity to learn from this visitor, may have chosen short-term control over long-term understanding, may have prioritized avoiding panic over acquiring knowledge. And if 3I Atlas was artificial, if it was a probe that we could have studied more thoroughly, if all the data had been released immediately to the global research community, then the silence becomes more than just information control, becomes a lost chance to understand technology from beyond, to learn from a civilization capable of crossing interstellar distances, to potentially advance our own capabilities by studying what they built. That's the cost of the cover-up. If there is a cover-up, not just the dishonesty, not just the erosion of trust in scientific institutions, but the lost knowledge, the missed opportunity to learn from something that might not come again in our lifetimes or our civilization's existence. The countdown to Jupiter continues. The observations are being prepared, the instruments are being calibrated, And in January 2026, we'll see what we'll see. We'll capture what images we can. We'll record what spectra we're able. We'll measure what the object does as it passes through the most extreme environment it will encounter in our solar system. And we'll analyze, we'll debate, we'll draw conclusions from incomplete data and argue about interpretations and publish papers that contradict each other and slowly, incrementally build understanding from the fragments of observation we manage to collect. That's how science works when it works properly. Multiple observers, multiple perspectives, open data, transparent methods, conclusions that emerge from collective effort rather than being dictated by authority. But it's not how science is working with 3i Atlas. And that's the real anomaly, not the object's behavior, however unusual, but our response to it, the coordination, the control, the sudden unified messaging that looks more like political management than scientific investigation. Something changed on December 25th. The narrative shifted, the silence descended, and now we wait to see if Jupiter breaks it or reinforces it. If the test reveals truth, or just generates more questions wrapped in more carefully managed statements, the visitor is leaving, the mystery remains, and the silence continues, fragile but maintained, waiting for the moment when it either shatters completely or solidifies into accepted history that 3i Atlas was interesting but natural, and nothing more needs to be said. We're watching, listening, analyzing what we can, pushing for transparency even as we're told to trust official statements, refusing to let the story die quietly even as the object fades from our instruments. Because this matters, whether it's natural or artificial, whether we're being visited or just witnessing exotic phenomena, whether the silence is prudent information management or deliberate cover-up. This is the story that could redefine humanity's understanding of the cosmos and our place in it, and it's being hidden, controlled, managed by people who think they have the right to decide what the rest of us can know. But the truth doesn't care about information management, doesn't respect classification protocols, and Jupiter is coming, bringing observations that might be impossible to suppress or explain away. The countdown is on. The test approaches, and whatever emerges from that encounter, whatever the instruments capture and the observers witness, will be the next chapter in a story that started with discovery and is building toward either revolution or vindication. Keep watching, keep questioning, keep demanding transparency, because the only way truth emerges from silence is if people refuse to accept the silence as final. 3i Atlas is leaving. But the questions remain, and they won't be answered by official statements that omit more than they reveal, only by data, only by observation, only by the patient work of analysis that follows evidence wherever it leads, regardless of how uncomfortable the destination might be. The visitor came, the visitor challenged us, and now the visitor speeds toward Jupiter, carrying secrets that might be revealed or might be kept forever, depending on what we see and what we're allowed to say about what we see. The age of isolation is ending, whether that means we're joining a populated galaxy or just that we're learning to detect the natural traffic between stars. The cosmos is more active than we thought, more connected, more full of travelers moving between systems on timescales we're only beginning to measure. And 3i Atlas, whatever it ultimately proves to be, has shown us that we need to watch more carefully, need to be ready for visitors who might not announce themselves clearly, need to develop capabilities for distinguishing between natural wanderers and designed artifacts because the difference matters and the current tools aren't adequate. The journey continues. The mystery deepens, and Jupiter waits, ready to test the visitor and reveal whether the silence was prudent or whether it was hiding the most important discovery in human history. Watch the skies, question the narratives, and never accept that silence means there's nothing to say. Sometimes silence is the loudest statement of all.